The night of May 5th to 6th, 1943, edge of the Grand Banks, North Atlantic. A merchant ship's cook, Flower still dusting his hands from the evening meal prep, rushes to his action station as the alarm bells clang through the corridors. His station isn't in the galley where soup still bubbles on the stove. It's at the snowflake flare locker on the weather deck. What happens next seems like madness. In the middle of absolute blackout conditions, with 40 German U-boats prowling the darkness around Convoy ONS 5, this cook begins firing parachute flares into the night sky. One after another, the brilliant white stars burst overhead, turning night into day, illuminating the convoy like a theatre stage. Cursing erupts from the bridge about blackout violations. Yet from the escort vessels comes a different cry. Keep them coming. The flares drifted down on their parachutes, casting harsh shadows across the water. In that artificial daylight, the conning towers of surfaced U-boats become visible at the convoy's edge. On the escort ships, centimetric radar screens suddenly bloom with clear returns. The submarines caught in the light are forced to crash, dive, or alter course. In the space of minutes, the hunters become the hunted. Who in their right mind turns on the lights in the middle of a wolfpack attack? The answer lies not in desperation, but in calculated doctrine, technological convergence, and a revolution in anti-submarine warfare that would help turn the tide of the Battle of the Atlantic. The convoy struggles through force, 10 winds at 7.5 knots, approximately 13.9 kilometers per hour, while visibility drops to barely 100 yards in the spray and darkness. The escort vessel's new 10-centimeter radar systems pick up surfaced U-boats at 3,600 yards, roughly 3.3 kilometers, cutting through the murk that blinds human eyes. More than 40 submarines have converged on this convoy of 43 merchant ships. This is the crescendo of what the Germans would later call Black May, though they don't know it yet. To understand why a cook firing flares into the darkness wasn't suicidal stupidity, but tactical brilliance, we need to go back 3 years. From 1940 through 1942, German U-boats perfected the surface night attack. Commanders like Otto Kretschmer would slip through escort screens on the surface, invisible in the darkness, penetrating deep into convoy formations. At ranges under 2,000 yards, they would fire their torpedoes with deadly precision. One torpedo, one ship. The submarine stayed on the surface where it could use its diesel engines, achieving speeds of 17 knots, faster than most convoy escorts could manage in rough seas. Between March and May of 1941 alone, U-boats sent over 140 merchant ships to the bottom using these tactics. The standard convoy formation stretched across the ocean in 8 to 10 columns, ships spaced roughly 1,000 yards apart, both laterally and in line ahead. The entire formation moved at the speed of the slowest vessel, typically 7 to 9 knots. The mathematics were brutal in their simplicity. A surfaced U-boat could overtake a convoy, position itself ahead, then slip into the formation under cover of darkness. The first indication of an attack was usually the flash of a torpedo explosion against a merchant ship's hull. The convoy system itself wasn't new, it dated back centuries. But the industrial scale of the Second World War's convoy battles was unprecedented. The North Atlantic convoy cycle ran like clockwork. HX convoys fast from Halifax, SC convoys slow from Sydney, ON convoys outbound to North America, ONS convoys outbound slow. Each week during peak periods, more than 350 ships crossed the North Atlantic in these regulated formations. The pressure on escort allocation, refueling, and crew endurance was relentless. Enter the technological revolution. By late 1942, Type 271 radar sets operating on 10-centimeter wavelengths began appearing on British escorts. The American SG radar followed soon after. These systems could detect a surfaced submarine's conning tower at several thousand yards, even in fog, rain, or darkness. Simultaneously, high-frequency direction-finding equipment, HFDF or HUF-DUF to its operators, allowed escorts to triangulate U-boat radio transmissions from hundreds of nautical miles away. A submarine reporting a convoy sighting to headquarters instantly revealed its bearing to every HFDF-equipped escort. But technology alone wasn't enough. The flare illumination question had divided naval tacticians since 1940. Absolute blackout had been gospel. Any light would betray the convoy's position to submarines prowling the horizon. Yet, escort commanders noticed something crucial. U-boats attacking on the surface at night relied on silhouettes against the sky to aim their torpedoes. If you could force them underwater with illumination, they lost their speed advantage and became vulnerable to ASDIC, the sonar system that could track submerged submarines. The disaster experiences of 1941 and early 1942 proved the critics right initially. Merchant ships firing flares indiscriminately served as beacons for wolf packs. One convoy in March 1942 lost 3 ships in an hour after panicked flare launchers revealed its position from 10 nautical miles away. The white light destroyed night vision. Lookouts who stared at flares needed several minutes to recover their ability to spot torpedo wakes or periscope feathers in the darkness. One survivor described it. We lit ourselves up like a Christmas tree and invited our own destruction. Consider the cook on that merchant ship. Not a professional naval gunner, but a civilian volunteer trained hastily for his action station. Maritime labour was stretched so thin that everyone pulled double duty. Cooks, engineers, deckhands all manned secondary positions during action stations. The cook's training on the flare launcher might have consisted of a 30-minute session in port. His primary job was feeding 40-odd merchant sailors 3 meals a day in seas that could throw pots off stoves. Now he stood at a rocket launcher, trying to remember the firing sequence while the ship rolled 20 degrees to each side. The snowflake rockets themselves were deceptively simple. Magnesium flares on parachutes, fired from tubes or projectors, designed to burn for 30 to 60 seconds while drifting down from several hundred feet. Each flare could illuminate several thousand square meters of ocean surface, but timing was everything. Fire too early and you revealed your position. Fire too late and the submarine had already launched its torpedoes. Fire without coordination and you blinded your own escort's lookouts while helping the enemy. The night of May 4th to 5th, 1943, changed everything. The convoy ONS-5 had already been under attack for 5 days. Weather conditions were abysmal. Force 10 winds, massive seas, intermittent fog banks where warm Gulf Stream water met the cold Labrador current. Visibility dropped to 100 yards, then 500, then back to 0. The convoy's speed had fallen to 5 knots as ships struggled to maintain formation. At this rate, they were sitting ducks for the wolf pack that German naval headquarters had vectored onto them. But conditions that challenged the convoy also challenged the attackers. U-boats couldn't maintain visual contact in the fog. Their lookouts, swept by spray on the conning towers, could barely see their own bow waves. They relied on radar, primitive sets that the new Allied 10-centimeter radars could actually detect in passive mode. The German search receivers, designed to detect the older meter wavelength radars, couldn't pick up the new centimetric emissions. The U-boats were electronically blind to their electronic detection. Commander Peter Gretton of Escort Group B7 had drilled his ships relentlessly in a new doctrine codenamed Operation Raspberry. When HF, DF, or radar-detected U-boats massing for attack, Designated merchant ships would fire illumination rockets in coordinated patterns, not randomly but in specific sectors, creating a ladder of light stepping outward from the threatened flank. The escorts, already vectored by radar and HF-DF, would charge toward the illuminated zones at maximum speed. The combination was lethal: radar for detection, flares for visual confirmation and forcing crash dives, ASDIC for underwater tracking, then depth charges or the new Hedgehog ahead throwing weapons for the kill. At 02:15 hours on May 6th, the radar operator on HMS Duncan called out contact bearing 045, range 3,600 yards. The escort commander ordered illumination pattern Raspberry 2. On the merchant ship Norse King, the cook at action stations received the signal via sound-powered phone. He pulled the first rocket from its waterproof container, slotted it into the launcher, and yanked the firing lanyard. The flare whooshed upward, bursting at 800 feet. The parachute deployed and sudden white light flooded down onto the sea. There, caught like a spotlight actor who'd missed his cue, sat U-954 on the surface, closing for attack. The submarine's lookouts, blinded by the sudden illumination, shouted the crash dive alarm. But HMS Duncan was already racing in at 18 knots, her ASDIC operator ready. As U-954's conning tower disappeared, the escort ship's sonar beam found her. The tactical plot showed the submarine turning hard to port, diving steeply. Duncan crossed overhead and dropped a pattern of 10 depth charges set for 150 feet. The sea erupted in towering columns of white water. Oil and debris surfaced minutes later. The Convoy's cook fired another flare, then another, maintaining the ladder pattern as ordered. Each rocket illuminated a different sector, forcing any surfaced submarine to dive or reveal itself for surface gunfire. Corvette HMS Snowflake spotted U-531 attempting to escape on the surface and opened fire with her 4-inch gun at 2,000 yards. The submarine dove, but Snowflake had her on ass deck. A pattern of 14 depth charges followed. More oil, more debris. 2 U-boats destroyed in 20 minutes using the coordinated illumination tactics. The mathematics of anti-submarine warfare had shifted decisively. When radar could detect a surfaced submarine at 3,600 yards, and the submarine needed to close within 2,000 yards for an effective torpedo shot, the escort had roughly 6 to 8 minutes to intercept if both vessels maintained typical speeds. The submarine at 12 to 14 knots, the escort at 15 to 20 knots in these sea conditions. Add illumination forcing an emergency dive, and the submarine's speed dropped to 7 knots submerged while becoming visible to ASDIC. The Hunter's advantage evaporated. The Hedgehog weapon system added another lethal dimension. Unlike depth charges that exploded at preset depths whether they hit anything or not, Hedgehog fired 24 contact-fused projectiles in an elliptical pattern 200 to 250 meters ahead of the attacking ship. The projectiles only exploded on contact with a submarine's hull, meaning a miss didn't disturb the water and lose ASDIC contact. The escort could immediately adjust and fire again. The kill probability rose from roughly 7% with depth charges to over 20% with Hedgehog. By dawn on May 6th, Convoy ONS-5 had survived the night. 6 U-boats had been destroyed, 7 heavily damaged for the loss of 13 merchant ships over the entire week-long battle. The exchange ratio, a critical metric in attrition warfare, had flipped. Previously, U-boats might sink 5 or 6 merchants for every submarine lost. Now they were losing submarines faster than they could sink ships. The temporary advantage of illumination that night was part of a larger pattern that would define May 1943 as the turning point of the Battle of the Atlantic. The cook on the merchant ship, exhausted after hours at his action station, probably didn't realize he had participated in a revolution. He was one small part of an elaborate system: HF-DF operators tracking radio transmissions, radar operators reading glowing screens, AS-DIS operators listening to the ethereal pings of sonar returns, escort commanders coordinating attacks, and yes, merchant sailors firing flares at precisely calculated moments. Each element alone was vulnerable. Combined with split-second timing and iron discipline, they formed an interlocking system that broke the U-boat threat. The transformation didn't happen overnight. It emerged from 3 years of bitter experience, technological development, and operational analysis. The British Operational Research Section studied thousands of convoy battles, measuring everything: optimal convoy size, escort positioning, depth charge patterns, search patterns, illumination timing. They discovered, for instance, that larger convoys were actually safer than smaller ones. The perimeter to area ratio meant fewer escorts could protect more ships. A convoy of 60 ships needed barely more escorts than a convoy of 30, but transported twice the tonnage. American industrial muscle accelerated every aspect of the campaign. The United States built 2,400 Liberty ships during the war, averaging 3 days from keel laying to launch at peak production. Shipyards operated 24 hours a day, 7 days a week. By mid-1943, Allied shipbuilding outpaced sinkings by 300% monthly. The convoy system could afford losses that would have been catastrophic earlier in the war, because replacement ships were sliding down the ways faster than U-boats could sink them. The training infrastructure expanded equally dramatically. Camp Peary in Virginia processed thousands of merchant mariners monthly. Basic seamanship, damage control, gunnery, firefighting, compressed into weeks what peacetime training spread over months. The cook who manned the flare launcher on ONS-5 might have been selling insurance 6 months earlier. The radar operator reading returns might have been a bank clerk. Total war demanded total mobilization, and the convoy system absorbed everyone from teenagers to men in their 60s. Consider the electronic warfare dimension that night. The German B-Dienst intelligence service had broken British naval codes earlier in the war, allowing U-boat headquarters to vector wolf packs onto convoy routes with deadly precision. By 1943, the Allies had not only changed their codes, but were reading German naval Enigma traffic almost in real time. Convoy routes could be adjusted to avoid known U-boat concentrations. When contact was unavoidable, as with ONS-5, the escorts knew approximately how many submarines they faced and from which directions. The U-boats at ONS-5 operated under their own tactical doctrine. Admiral Karl Dönnitz's Wolfpack tactics called for the first submarine to spot a convoy to shadow it while transmitting position reports. These reports, sent on high frequency to ensure reception at headquarters in France, were precisely what HF-DF operators listened for. A submarine maintaining contact had to transmit every few hours, and each transmission revealed its bearing to every Allied escort within hundreds of miles. The German tactical innovation of coordinated attack became a vulnerability when the enemy could track coordination signals. The fog and storms around ONS-5 created layers of tactical complexity. Temperature gradients where the Gulf Stream met the Labrador Current bent sonar beams unpredictably. A submarine at 200 feet might be invisible to AS-DIC in these conditions, hidden below a thermocline that reflected sound waves. Surface radar returns fluctuated wildly as wave heights exceeded 30 feet. In these conditions, forcing submarines to dive through illumination became even more critical. It pushed them into depth bands where Dick could maintain contact despite the challenging water conditions. Operation Raspberry wasn't simply about firing flares. It was about synchronized multi-platform engagement. When the cook pulled that firing lanyard, his action triggered a cascade of coordinated responses. The escort commander had already positioned his ships based on HF-DF bearings. Radar operators were scanning specific sectors. ASTIC operators had their equipment tuned for the local water conditions. Depth charge crews had their weapons set for probable diving depths based on water temperature and current. The illumination was merely the visible component of an invisible kill chain. The production statistics behind that night's action stagger the imagination. Each depth charge contained 300 pounds of high explosive. A typical attack pattern of 14 charges represented 2 tons of explosives delivered in seconds. HMS Duncan alone carried over 100 depth charges, 15 tons of explosive power. The entire escort group B7 carried enough depth charges to deliver over 100 tons of high explosive. These weapons had to be manufactured, shipped across the Atlantic, loaded under combat conditions, maintained in salt spray and violent weather, then delivered with precision timing. The logistical chain stretched from explosive factories in the American Midwest to the North Atlantic killing grounds. TNT production at the Volunteer Ordnance Works in Tennessee reached 144,000 pounds daily by 1943. Railway cars carried the explosive to ammunition plants where it was packed into depth charge cases manufactured in Detroit using steel from Pittsburgh. Ships transported the finished weapons to bases in Iceland, Newfoundland, and Britain, where they were loaded onto escorts between convoy runs. Each escort vessel consumed roughly 5 tons of depth charges per week during peak combat periods. Fuel consumption added another logistical dimension. An escort destroyer burned approximately 100 tons of fuel oil during a typical Atlantic crossing. The convoy's merchant ships consumed thousands more tons collectively. Refueling at sea, a dangerous operation in calm weather, nearly suicidal in North Atlantic storms, became routine necessity. The oiler British Lady, accompanying ONS-5, performed multiple underway refueling operations during the battle, maintaining convoy speed while pumping fuel oil through hoses stretched between ships rolling in 40-foot seas. The human dimension often gets lost in the statistics. Merchant sailors faced a roughly 25% casualty rate during the war, higher than most combat branches of military service. If your ship was torpedoed in the North Atlantic, survival time in the water averaged less than 15 minutes before hypothermia proved fatal. The cork life jackets of the era provided buoyancy but little thermal protection. Lifeboats launched successfully faced mountainous seas, freezing spray, and the constant danger of being run down in darkness by their own convoy, which couldn't stop to search for survivors. The escort crews endured different but equally harsh conditions. A corvette like HMS Snowflake, 180 feet long with a 33-foot beam, rode the Atlantic swells like a cork. In heavy weather, the ship could roll 45 degrees, pitch 30 degrees, and launch completely clear of the water before crashing down with hull-shaking impacts. Crew members described being thrown from their bunks, unable to cook hot food for days, constantly soaked by water penetrating every hatch and ventilator. Yet they had to maintain precise station keeping, operate complex electronic equipment, and fight their ship effectively when combat came. The communication networks that coordinated the battle stretched across continents. The Admiralty's Operational Intelligence Centre in London tracked every convoy, every escort, every known U-boat position. The information flowed through undersea cables, radio networks, and courier services. Weather reports from Greenland informed routing decisions. Intelligence from resistance networks in French ports revealed U-boat departures. Code breakers at Bletchley Park decoded German naval signals within hours of transmission. All this information converged on convoy commanders like Peter Gretton, who had to make split-second tactical decisions in the chaos of night combat. By May 10th, 1943, the battle for ONS-5 had ended. The convoy's survivors reached port having witnessed something unprecedented: a wolf pack beaten off with catastrophic losses. Across the Atlantic, similar battles produced similar results. In that single month, Black May, the German U-boat force lost 41 submarines. The mathematics of the tonnage war had reversed decisively. Admiral Dönitz withdrew his submarines from the North Atlantic convoy routes on May 24th, effectively conceding defeat in the decisive theater of the naval war. The strategic implications rippled outward immediately. With the North Atlantic convoy route secured, the build-up for the invasion of Europe could begin in earnest. Operation Bolero, the transfer of American forces to Britain, accelerated from thousands of troops monthly to hundreds of thousands. The 1,000 bomber raids against German industry became possible because aviation fuel flowed reliably across the Atlantic. The Red Army received Lend-Lease supplies that helped sustain their offensives. 400,000 trucks, 2 million tons of food, 15 million pairs of boots. Every ton of cargo that crossed the Atlantic represented strategic capability that the secure convoy routes enabled. The industrial feedback loop accelerated. Operational research teams analyzed every aspect of convoy battles, identifying optimization opportunities. The spacing between ships in convoy columns was adjusted based on torpedo spread patterns. Escort search patterns were refined using probability mathematics. The optimal size for convoy formations was calculated at 45 to 60 ships. Large enough for efficient escort allocation, but small enough for manageable command and control. Even the timing of illumination rockets was specified in detailed tables based on radar range, wind speed, and sea state. The training systems evolved equally rapidly. Mock convoy exercises off the American East Coast replicated Atlantic conditions. Merchant gun crews fired at target sleeves towed by aircraft. Communications teams practiced encrypted radio procedures until they could transmit convoy course changes in seconds. Engineering officers learned to repair radar systems using improvised parts. The entire Allied maritime force became a learning organization, adapting faster than their opponents could counter. The technological race continued through 1943 and beyond. The Germans introduced the acoustic homing torpedo, which tracked the sound of ship propellers. The Allies countered with the Fokker noisemaker, towed behind ships to decoy acoustic torpedoes. The Germans deployed radar warning receivers. The Allies shifted to centimetric frequencies the German equipment couldn't detect. Each innovation triggered counter-innovation in a high-stakes game of technological leapfrog, where failure meant ships and sailors on the ocean floor. But technology alone never won the battle. The victory emerged from systems integration: radar, sonar, communications, weapons, tactics, training, logistics, intelligence, all synchronized into an effective whole. The merchant cook firing those flares on May 6th was one node in a network that stretched from factory floors to cabinet war rooms. His simple action, pulling a lanyard at the right moment, only mattered because thousands of other people performed their functions with equal precision. The records from ONS-5 provide extraordinary detail about those critical hours. At 02:15 hours, first radar contact. At 02:17, illumination commenced. At 0221, first depth charge attack. At 0228, oil and debris sighted. The engagement lasted 4 hours, with illumination rounds fired every 1 to 2 minutes during peak action. Escort ammunition expenditure: 300 depth charges, 500 rounds of 4-inch ammunition, 2,000 rounds of smaller caliber. The merchant ships fired over 200 illumination rockets. Each number represents split-second decisions under extreme pressure, executed by exhausted men who hadn't slept properly in days. The weather moderated slightly by dawn on May 6th, winds dropping to force 8, visibility improving to 1 nautical mile. The convoy reformed its columns, counted its survivors, and pressed onward at 7.5 knots. The escorts refueled from British Lady while maintaining anti-submarine vigilance. Damage control parties repaired weather damage, radio operators transmitted position reports and received routing updates. The military-industrial symphony continued without pause, because pausing meant giving the U-boats time to reconcentrate. The German submarine force never recovered from Black May. They would continue fighting until the war's end, but the tonnage war was lost. New submarine technologies, the Type Waiter 1 with its high underwater speed, the snorkel for submerged diesel operation, arrived too late and in too few numbers. The institutional knowledge built over 3 years of successful Wolfpack operations died with the veteran crews lost in mid-1943. By war's end, the U-boat force had lost 793 submarines and 30,000 sailors, a 75% casualty rate, among the highest of any military service in history. The Allied victory in the Battle of the Atlantic wasn't inevitable. It resulted from deliberate choices, systematic analysis, and disciplined execution. The American contribution, industrial production, operational research, technological innovation, crew training, provided critical mass that tipped the balance. But equally important was the integration of Allied efforts: British experience, Canadian persistence, Norwegian sailors, Polish code breakers, Free French intelligence. The convoy system became a truly Allied enterprise, where national boundaries mattered less than operational effectiveness. The revolution in anti-submarine warfare influenced naval doctrine through the rest of the 20th century. The concept of forcing adversaries to reveal themselves, exemplified by those illumination flares, evolved into modern tactical concepts. Today's naval forces use active sonar pulses, electromagnetic emissions, and other signatures to force submarines from hiding. The basic principle remains unchanged. Deny the enemy the advantage of concealment, force them into domains where your sensors and weapons are superior, then execute the kill chain with disciplined precision. The merchant sailors who survived ONS-5 rarely spoke of their experience in heroic terms. They did their jobs, standing watches, maintaining machinery, firing flares when ordered, because that's what the situation demanded. The cook who manned that rocket launcher returned to his galley once the all-clear sounded, serving breakfast to exhausted sailors as the convoy plowed onward through moderating seas. His flour-dusted hands had helped win one of the Second World War's decisive battles, though he probably thought of it as just another rough night on the North Atlantic run. The convoy system's success rested on such ordinary people performing extraordinary tasks under impossible conditions. They weren't warriors by training or temperament. They were civilians who found themselves at the sharp end of total war, adapted to its demands, and prevailed through discipline and determination. The organizational systems that supported them, training programs, supply chains, command structures, technical development, represented American industrial democracy mobilized for war. Efficiency, standardization, mass production, systematic improvement, These distinctly American strengths found their expression in the convoy battles of 1943. As we examine that night of May 5th to 6th more closely, certain moments stand out with crystalline clarity. The cook stands at his action station, salt spray soaking through his pea coat, hands numb from cold, counting down seconds on the bridge. Chronometer relayed through sound-powered phones. "Fire one," comes the order. He pulls the lanyard. The rocket whooshes upward, trailing sparks. For a moment, nothing changes. Then the parachute deploys, and brilliant white light floods down onto the heaving seas. In that magnesium glare, the war's arithmetic shifts fractionally but decisively toward Allied victory. The tactical innovation of coordinated illumination, Operation Raspberry, succeeded because it exploited multiple German vulnerabilities simultaneously. U-boats depended on surface mobility for tactical advantage. Force them underwater, and they lost 70% of their speed. They relied on visual targeting for torpedo attacks. Blind them with light, and they couldn't aim accurately. They needed radio coordination for wolfpack tactics. Those transmissions revealed their positions to HF-DF. They assumed darkness provided concealment. Centimetric radar penetrated that darkness, and illumination confirmed radar contacts for optical engagement. Each vulnerability alone was manageable. Together, they proved fatal. The learning curve steep, but measurable. In 1941, uncoordinated flare use caused more harm than good. By mid-1942, escort groups began experimenting with controlled illumination patterns. The disaster of Convoy SC-107 in November 1942, 15 ships lost, prompted intensive tactical review. Operational researchers calculated optimal flare patterns, timing sequences, and coordination procedures. By early 1943, formalized doctrine emerged. ONS-5 in May 1943 demonstrated the mature system in action. The progression from chaos to competence took 18 months of combat learning. Behind every tactical innovation lay industrial capacity. The 2 million snowflake rockets produced during the war required magnesium, aluminum powder, potassium nitrate, and specialized manufacturing equipment. Magnesium production alone consumed enormous electrical power, 15,000 kilowatt hours per ton. The Dow chemical plant in Texas, powered by natural gas generators, produced much of America's magnesium using seawater as raw material. From Gulf of Mexico brine to North Atlantic illumination, the supply chain stretched 3,000 miles but delivered reliably. The convoy communication systems deserve special attention. Each merchant ship carried multiple radios but maintained radio silence, except in extreme emergency. Orders passed through signal lamps, flag hoists, or low-power TBS, talk between ships. Radio. The convoy commodore, usually a retired naval officer sailing aboard one of the merchant vessels, coordinated movements using these limited channels. Imagine controlling 43 ships in formation through a North Atlantic gale using light signals barely visible at 500 yards. Yet the system worked, maintaining cohesion under the most challenging conditions imaginable. The escort commanders operated in a different information environment. They received ultra-intelligence about U-boat positions, HF-DF bearings on submarine transmissions, radar contacts from multiple ships, ASTIC returns, visual reports, and tactical guidance from Western Approaches Command. Processing this information flow while fighting their ships through mountainous seas required exceptional cognitive ability. Commander Gretton of B7 had been at sea almost continuously for 2 years, grabbing sleep in 20-minute intervals between actions. Yet, he maintained tactical clarity throughout the week-long battle around ONS-5. Examining the German perspective reveals the totality of their defeat. U-boat command monitored the battle through radio reports from attacking submarines. As boats fell silent one after another, the tactical picture became clear. The convoy wasn't just defending itself, but actively hunting its attackers. U-223's final transmission reported being illuminated and depth-charged. U-192 signaled heavy damage from escort gunfire after being caught on the surface. U-954 simply vanished, its destruction confirmed only post-war when records were cross-referenced. The wolf pack that had seemed invincible in 1942 was being systematically destroyed. The aftermath of Black May resonated through both navies. The Allies pressed their advantage, introducing escort carriers that extended air cover across the entire Atlantic. The new Mark 24 acoustic homing torpedo, dropped from aircraft, gave maritime patrol planes a precision weapon against submerged U-boats. Magnetic anomaly detection equipment allowed aircraft to find submerged submarines in shallow water. The technological advantage, once achieved, widened relentlessly. By late 1943, crossing the Atlantic had become safer statistically than training exercises off the American coast in 1942. The Germans attempted numerous countermeasures. The Type 81 submarine, with its streamlined hull and massive battery capacity, could sustain 16 knots submerged, faster than most convoy escorts. But production delays meant only 2 Type 281s became operational before war's end. The Snorkel, allowing submarines to run diesel engines while submerged, offered tactical advantages but couldn't overcome the fundamental arithmetic. The Allies were building ships faster than U-boats could sink them, and killing U-boats faster than Germany could replace them. Human factors proved equally decisive. The veteran U-boat commanders who had devastated Allied shipping in 1940 to 1942 were mostly dead by mid-1943. Their replacements, rushed through truncated training programs, lacked the experience for successful attacks against well-defended convoys. Meanwhile, Allied escort crews accumulated experience with each crossing. A corvette captain who survived 10 convoy runs had seen more anti-submarine combat than most naval officers experienced in entire peacetime careers. This experience differential compounded with each passing month. The economic impact extended far beyond shipping losses. Germany invested enormous resources in the U-boat campaign. Steel, copper, precision machinery, skilled labor, training facilities, fuel oil. By one estimate, the resources consumed building and operating one U-boat could have produced 50 tanks or 200 fighter aircraft. The Allied investment in convoy defense was equally massive, but supported by far greater industrial capacity. The United States alone produced more steel in 1943 than Germany, Japan, and Italy combined. This industrial asymmetry meant the Allies could afford the convoy system's costs, while the Germans couldn't sustain U-boat losses. The intelligence dimension remained crucial throughout. The British Government Code and Cipher School at Bletchley Park read German naval enigma traffic with varying success throughout the war. Periods of blackout when code changes temporarily blocked decryption corresponded with increased shipping losses. But by May 1943, Allied codebreakers were reading U-boat communications almost in real time. Convoy ONS-5's route was adjusted 3 times based on decoded German messages, revealing U-boat concentrations. Without ultra-intelligence, the convoy might have sailed directly into the Wolfpack's optimal interception position. Simultaneously, German intelligence failed catastrophically. They never realized the Allies were reading their codes. They didn't detect the introduction of centimetric radar until captured equipment revealed its existence. They underestimated Allied shipbuilding capacity by 60%. They assumed the convoy system would collapse under sustained pressure, not recognizing its inherent resilience. These intelligence failures meant U-boat headquarters was fighting blind while believing they had perfect situational awareness, a fatal combination in warfare. The weather itself became a factor in the tactical equation. The North Atlantic in winter and spring presented conditions that pushed men and machines to their limits. Hurricane force winds, 60-foot waves, ice accumulation on deck equipment, visibility near zero in snow and spray. Yet these same conditions that made convoy operations miserable also complicated U-boat attacks. Torpedoes ran erratically in heavy seas. Submarines couldn't maintain periscope depth in massive swells. Radio communications became unreliable. The weather, that seemed to favor the attacker, actually degraded their capabilities more than it hindered the defense. Returning to our cook at the flare launcher, his story represents millions of similar stories, ordinary people thrust into extraordinary circumstances, performing critical tasks with discipline and courage. He probably never thought of himself as a warrior. Before the war, he might have worked in a restaurant, a factory, a farm. The war transformed him into a small but essential component of the most complex military-industrial enterprise in human history. His flour-dusted hands on that rocket launcher helped secure the Atlantic bridge that carried the materials of victory to every Allied theater. The organizational achievement represented by the convoy system staggers the imagination even today. Coordinating thousands of ships, hundreds of thousands of sailors, millions of tons of cargo across an ocean under enemy attack in the worst weather conditions on Earth, and doing it successfully week after week for years. The American contribution to this achievement went beyond ships and weapons. It included management techniques, operational research methods, training systems, and above all, the disciplined application of industrial-scale problem-solving to warfare. The Battle of the Atlantic was ultimately won in shipyards, factories, training centers, and laboratories as much as on the ocean itself. Every Liberty ship launched, every radar set manufactured, every sailor trained. Every operational analysis completed contributed incrementally to victory. The convoy system represented democracy's answer to totalitarian aggression, not individual heroism, though there was plenty of that, but systematic, organized collective effort directed toward a common goal. The cook firing flares and the president directing strategy were part of the same continuum of democratic mobilization. As dawn broke fully on May 6, 1943, Convoy ONS-5 had survived its trial by fire. The exhausted merchant crews secured from action stations, assessed damage, treated wounded, and prepared for another day's steaming toward port. They had no way of knowing they had participated in the turning point of the longest campaign of the Second World War. To them, it was simply another night of terror and survival on the North Atlantic run. But in the larger sweep of history, their successful defense marked the moment when the U-boat threat crested and began its inexorable decline. The technical details matter because they reveal how victory was constructed from countless small advantages aggregated into overwhelming superiority. 10-centimeter radar gave a few thousand yards extra detection range. HFDF provided bearing accuracy within 2 or 3 degrees. Hedgehog increased kill probability by 15%. Coordinated illumination reduced submarine attack effectiveness by forcing crash dives. Each improvement seemed marginal in isolation. Combined systematically, they transformed the correlation of forces in the Atlantic War. The production statistics from 1943 illuminate American industrial mobilization. Monthly merchant ship production, 170 vessels averaging 8,000 tons displacement. Monthly aircraft production for maritime patrol, 300 long-range bombers modified for anti-submarine warfare. Monthly depth charge production, 50,000 units. Monthly radar set production, 2,000 units of various types. These numbers represent not just industrial output, but the transformation of American society. Millions of workers, many of them women, laboring around the clock to feed the machinery of war. Training statistics were equally impressive. The Merchant Marine Academy at Kings Point, New York, graduated 2,500 officers annually by 1943. Enlisted training centers processed 40,000 merchant sailors per year. Navy schools trained 15,000 radar operators, 10,000 sonar operators, 8,000 radio operators annually. Each graduate represented weeks or months of intensive instruction compressed from peacetime curricula that stretched over years. The quality of training might have been variable, but the quantity was overwhelming. The Allies could afford learning curves that the Germans couldn't match. The financial cost reached astronomical proportions. The United States spent roughly $300 billion on World War II, equivalent to several trillion in modern currency. The convoy system consumed perhaps 10% of this total. Escort vessel construction and operation, merchant ship replacement, port facilities, training establishments, weapons production, fuel, supplies, wages. The British investment was proportionally even higher, approaching national bankruptcy to maintain the Atlantic lifeline. Yet the alternative, starvation and defeat, made any cost bearable. The convoys had to get through regardless of expense. The strategic consequences of convoy success cascaded through every aspect of Allied war planning. Operation Torch in North Africa, Operation Husky in Sicily, Operation Overlord in Normandy, all depended on secure Atlantic communications. The bombing offensive against Germany required aviation fuel shipped from American refineries. The Soviet Union's survival through 1943 depended partially on Lend-Lease supplies convoyed through Arctic waters. China received supplies flown over the Himalayan hump using fuel shipped across the Pacific. The convoy system was the circulatory system of global Allied strategy. Even the Manhattan Project depended on convoy success. Uranium from the Belgian Congo, graphite from Canada, heavy water from Norway when available, specialized equipment from British laboratories, all moved by ship. The theoretical physicists at Los Alamos needed an uninterrupted flow of materials and equipment that only secure sea lanes could provide. In this sense, the atomic bombs that ended the Pacific War were enabled by convoy sailors who kept the Atlantic Bridge open through 1943's crisis months. The environmental impact of the Battle of the Atlantic remains visible today. Thousands of ships rest on the ocean floor. Merchant vessels, escorts, submarines, slowly releasing oil and other pollutants. The wrecks serve as artificial reefs, supporting marine ecosystems that didn't exist before the war. Ocean surveys regularly discover previously unknown wrecks, each a monument to the battle's intensity. The Gulf Stream and Labrador Current that created such challenging conditions for convoy operations continue their eternal circulation, indifferent to the human drama they once hosted. The last survivors of Convoy ONS-5 have passed away, taking their first-hand memories with them. But the records remain: logbooks, action reports, personal letters, photographs, charts, tactical analyses. From these fragments, we can reconstruct those desperate hours when a cook's hand on a flare launcher helped turn the tide of history. The moment seemed small, a tired man performing a simple mechanical task. Yet it exemplified the entire Allied war effort. Ordinary people, properly organized and equipped, accomplishing extraordinary things through disciplined collective action. The debate over convoy tactics continued long after the war. Some historians argue that resources devoted to convoy escort should have been used for offensive hunter-killer groups. Others contend that the convoy system was too defensive, allowing U-boats to choose when and where to attack. These arguments miss the essential point. The convoy system worked. It delivered the goods, preserved maritime communications, and ultimately broke the U-boat threat. Perfect tactics matter less than adequate tactics successfully executed, and the Allied convoy system achieved consistent, successful execution from mid-1943 onward. Modern naval strategists study the Battle of the Atlantic for lessons applicable to contemporary maritime challenges. The integration of sensors, weapons, and platforms into effective systems remains central to naval warfare. The importance of logistics and industrial capacity hasn't diminished. The challenge of protecting maritime communications against submarine threats continues with nuclear submarines and advanced conventional boats. The convoy experience of World War II provides the foundational case study for understanding these enduring challenges. The cultural memory of the convoys varies by nation. In Britain, the Battle of the Atlantic is remembered as a close-run thing that nearly brought starvation and defeat. In Canada, the convoy battles established the Royal Canadian Navy as a significant force. In Norway, the loss of merchant sailors, nearly 4,000 dead, represents the nation's primary Second World War sacrifice. In the United States, the convoy battles are often overshadowed by more dramatic Pacific naval engagements. Yet the Atlantic victory was arguably more strategically decisive, enabling every other Allied operation from 1943 forward. Technological evolution continued after the convoy battles. Nuclear submarines, satellite surveillance, precision-guided weapons, network-centric warfare. Each innovation changes tactical details while strategic principles endure. The need to protect maritime communications, concentrate force at decisive points, integrate multiple capabilities into coherent systems, maintain sustainable logistics flows. These requirements that shaped convoy operations remain relevant to contemporary naval planning. The cook at the flare launcher was participating in patterns of naval warfare that stretch from ancient galleys to modern carrier strike groups. The human dimension ultimately defines the convoy story. Behind every statistic was an individual, scared, exhausted, cold, seasick, but doing their job because others depended on them. The merchant sailor standing lookout in freezing spray, the escort radar operator staring at flickering screens for hours, the engineer nursing damaged machinery, the radio operator decoding messages with numb fingers. Each performed their function as part of an enormous organism dedicated to a single purpose: getting the convoys through. Their collective success represents one of human organization's great achievements under the most adverse conditions imaginable. As we reach the end of this account, let's return once more to that night of May 5th to 6th, 1943. The cook stands at his action station as dawn approaches. The flare attacks have subsided. The U-boats have withdrawn or been destroyed. The convoy reformation signal flags flutter from the Commodore's ship. Exhausted men, secure from action stations, grab what rest they can before the next alert. In a few hours, the cook will be back in his galley, preparing meals for hungry sailors. His brief time as an anti-submarine warrior concluded. He'll probably never speak of it much. There's nothing special about doing your job, after all. But that attitude, doing your job without fanfare, as part of something larger than yourself, exemplified the democratic arsenal that won the Battle of the Atlantic. Not individual heroism, but collective competence. Not brilliant improvisation, but disciplined execution of developed doctrine. Not technological magic, but systematic integration of multiple capabilities. The illumination flares that seemed like madness were actually manifestations of careful analysis, thorough preparation, and precise coordination. The cook pulling that lanyard was the visible tip of an enormous iceberg of organizational capability. The Battle of the Atlantic reached its climax in May 1943, when 41 U-boats were destroyed against rapidly declining merchant ship losses. The exchange ratio that had favored the attackers for 3 years reversed permanently. Convoy ONS-5, with its dramatic night action of coordinated illumination and escort attacks, exemplified this reversal. 6 U-boats destroyed, 7 damaged, for 13 merchant ships lost over a week. Painful but sustainable losses for the Allies, catastrophic for the Germans. The mathematics of attrition had shifted decisively. The convoy system's victory enabled everything that followed: the invasion of Europe, the bombing offensive, continued Soviet resistance, eventual victory in the Pacific. Without secure Atlantic communications, none of these strategic options would have been possible. The cook firing those flares, the escort commander coordinating attacks, the industrial workers producing weapons, the scientists developing radar, all were essential elements in democracy's answer to submarine warfare. Their combined efforts, multiplied across thousands of ships and millions of people, wrote victory onto the cold waters of the North Atlantic. In the final analysis, the Battle of the Atlantic was won by systems triumphing over tactics, organization defeating improvisation, industrial democracy overwhelming authoritarian efficiency. The U-boats were formidable weapons wielded by brave, skilled sailors. But they faced an integrated system of detection, tracking, engagement, and destruction that grew stronger with each passing month, while their own capabilities stagnated or declined. The illumination rockets that lit up the night of May 5th weren't acts of desperation, but expressions of confidence. We can see you, we can find you, we can kill you. The hunters had become the hunted. The cook returned to his galley as ONS-5 continued its passage to port. In a few days, he'd be unloading cargo, taking on supplies, preparing for the next voyage. The cycle would continue. Endless convoys crossing and recrossing the Atlantic, maintaining the lifeline that sustained Allied strategy. He probably never thought of his actions in strategic terms. He was just a cook who manned a flare launcher when the ship went to action stations. But multiply his story by millions, add technological innovation and organizational excellence, and you have the formula for victory in history's longest and most decisive naval campaign. The convoy system worked because it transformed ordinary people into extraordinary capabilities through training, equipment, and organization. The cook with flour-dusted hands became a night fighter. The bank clerk became a radar operator. The insurance salesman became a gunner. Democratic societies mobilized their entire populations, not just traditional warrior castes. This total mobilization, combined with industrial might and technological innovation, proved irresistible when properly organized and directed. The Battle of the Atlantic validated democracy's ability to defend itself against totalitarian aggression through collective effort and systematic excellence. The last word belongs to those who sailed the convoys. They faced the worst conditions nature could provide while under constant threat of enemy attack. They persevered through fear, exhaustion, and seemingly endless repetition of danger. They won not through individual brilliance, but through collective determination, maintaining discipline when everything seemed chaos, performing their duties when every instinct screamed for self-preservation. The cook at that flare launcher, representative of millions like him, demonstrated that ordinary people, properly organized and equipped, could accomplish the extraordinary. The lights he fired into the darkness didn't just illuminate U boats, they lit the path to Allied victory.